was a time of terror. An invincible force thundered on the face of the earth. A superstructure was the only defense. So strong, it could survive a nuclear blast. So powerful, its electronic eyes reached 23,000 miles into space. 1.5 million pounds of dynamite ripped 23,000 truckloads of solid granite from the heart of a Rocky Mountain to create an underground fortress of unprecedented size. Come inside this citadel, hidden deep within the earth, where high-tech sentinels guard America against annihilation. This is the secret world of NORAD. Cheyenne Mountain, a rugged Rocky Mountain peak rising boldly from America's vast central plains, just a few miles from the town of Colorado Springs. Deep within its 100-million-year-old granite heart lies one of mankind's most remarkable superstructures. A citadel of stone, steel, and microchips, where it is always twilight and no one ever sleeps. Instead, dozens of eyes maintain a second-by-second vigil over the skies around the world, looking for anything that could be the beginning of an attack on North America.
Suspect alert! Open up checklist 101112.
Sir, we got an unknown in the system.
Radar picks up an unidentified object in the skies over central Russia.
PST is reporting an Eastern Quick Alert from Plesetsk, Russia.
It's traveling fast and heading toward the Pacific Ocean.
Stand by for possible missile event.
CD copies. Intel, what is your analysis?
Prompt response is vital to the defense of the nation. Highly trained teams scan intelligence reports to determine the correct action.
Sir, Intel assesses this to be the scheduled launch of an ICBM from Plesetsk with impact expected at the Kamchatka Peninsula.
And Intel assesses this as troop training.
Though it's a scenario that has played out hundreds of times, the men and women on duty here know that a moment like this could be the one that puts them to the ultimate test.
NORAD, U.S. Space Complete, recommend we terminate this conference.
This is the headquarters of the North American Aerospace Defense Command, NORAD. Members of the United States Army, Navy, Air Force, Marine Corps, and the Canadian Armed Forces staff the NORAD operation centers. They work under the cover of a superstructure whose design and construction are as incredible as its high-tech capabilities. In a virtual world of computers, remote sensors, and speed-of-light telecommunications, they stand watch over the North American continent, perpetually devouring instantaneous data transmissions from a vast network of sensors on land, at sea, and in space. NORAD's eyes can not only see the entire surface of the Earth, they also gaze 22,500 miles up into the heavens, where they intently probe 27 trillion cubic miles of aerospace. From the smallest civilian airplane to the most sophisticated military satellite, nothing escapes them. NORAD personnel consider all airspace for 120 miles around the outer border of the United States and Canada critical to national security. It's called the Outer Identification Zone. NORAD must know the purpose of every aircraft there.
As soon as an aircraft crosses the Outer Identification Zone, we start a 2-minute clicker, so we've got to figure out who that track is within 2 minutes. And if we can't figure out who it is, or there's no way to correlate that with an FAA flight plan, we declare the track unknown, and that's when we scramble interceptors and go out and figure out who that is by putting eyes on the target.
Yes, sir. I just want to let you know that we have an unknown over Canada right now.
On a given day, we have anywhere from 6,500 to 7,200 tracks. We provide identification of every aircraft coming into North America. And that is a pretty sizable task given the fact that about 2.5 million tracks come into North America every year.
We are very rarely ever surprised in Cheyenne Mountain. We can't allow ourselves to be surprised.
NORAD U.S. Space has East DSP indication.
Cheyenne Mountain's labyrinth conceals NORAD's military wonders. Its existence has always been well known. Its tracking prowess is a matter of national pride. Its methods are top secret. How this superstructure came to be carved out of the inside of a mountain is one of the great feats of our century. 15 ingeniously constructed steel plate buildings house the command centers and the infrastructure that supports them through the endless hours of NORAD's vigilance. Stores of water, food, fuel, and a sophisticated air cleaning system provide life support for the complex. It can completely seal itself off from the outside world for more than 30 days.
Well, the first time I got here, I was lost. I really didn't know where I was going when you wander around because it's a pretty complicated complex inside. It's hard for people to imagine all the different levels of, different floors and different buildings that are here, and it's pretty overwhelming at first, but there's just a real sense of awe because the design is incredible. When you come into the large tunnel and through the blast doors and just realize what this was meant to survive, any kind of attack during the Cold War. And the engineering behind it is just amazing to me still.
I guess my first impression when I walked into Cheyenne Mountain was just to say, wow, what an engineering marvel. Even though it was constructed over 30 years ago, I continue to be amazed at the technology resonant within the mountain.
Getting all this technology inside a mountain was one of the 20th century's toughest engineering challenges. The builders wrenched 460,000 cubic yards of hard rock from the core of the mountain and replaced it with 7,000 tons of steel, yards of concrete, and miles of wiring. What drove men to hollow out a mountain and build this amazing superstructure? It was fear. In the 1940s and 50s, mankind unleashed the power of the stars on the face of the planet. Nuclear weapons darkened America's post-war optimism with fears of Armageddon. Could anything survive this unparalleled destructive force? To have any chance of winning the unthinkable war, America had to build something that could. No one was sure it was possible. At the beginning of the nuclear age, the technology to build a working city deep within a mountain, strong enough to endure a nuclear blast, did not exist. No one knew how many problems engineers would face once a project of this magnitude was started, or how innovative and creative they would have to be to solve those problems. The call went out to America's most talented engineers, challenging them to create something totally new to defend against phenomena whose effects were mostly unknown.
In fall of 1958, I received a call to go to Omaha to meet with the Corps of Engineers to discuss a project. And that's how it all began for me.
I didn't know anything about Colorado Springs, didn't know anything about NORAD at that time.
In the late 1950s, Tom Kiesel and Steve Greenfield were young engineers with the New York firm of Parsons Brinkerhoff. Greenfield had proven skills on some of his company's toughest projects. He specialized in hardened underground defense facilities. His work was often highly classified. Kiesel was more of a specialist in tunnel design and bridges. He brought innovative solutions to engineering problems. But nothing they had done prepared them for the mysterious, top-secret atmosphere of engineering North America's survival. The young engineers and their colleagues were given an unprecedented task: to design and build, quickly and economically, a fortress that could survive the unsurvivable, the power of a new weapon that for the first time in history could destroy the entire human race. A weapon that was now in the hands of America's enemy. In 1949, the Soviet Union detonated a nuclear device. Soviet bombers armed with nuclear weapons could strike North American cities. The nuclear superpowers settled into what they called Cold War, a permanent confrontation that could instantly turn hot.
When I was in the regular military, we had very regular military training for the future war against the Americans.
Colonel Stanislav Lunev is the highest-ranking Russian military intelligence officer ever to defect. He is currently in the Federal Witness Protection Program.
And I didn't know any other life than to live inside Cold War. We consider all this peacetime as some kind of break, which we have to train ourselves for the future war. Only break, peace break, that's all.
Duck and cover. Duck and cover.
In America, the Soviet threat gave birth to a massive campaign called civil defense.
You know how bad sunburn can feel. The atomic bomb flash could burn you worse than a terrible sunburn.
There was a turtle by the name of Bert.
While the public watched upbeat training films, federal and local authorities built shelters and tried to prepare for the worst.
Where we would hire architect engineering firms to go out and identify existing shelters and existing buildings, hallways, and then put up signs that this is a fallout shelter, and then eventually put in provisions, food and water, so that you could spend some time there till the fallout decayed enough to where it was safe to go outside.
This shelter is a real good idea. If we should ever have a nuclear war, we could get a heavy fallout even though we were not anywhere near the target area.
Hey, isn't this nice?
But thoughtful Americans wondered how much protection civil defense could offer against a nuclear onslaught. The key to survival was to stop an attack before it came. In 1957, Canada and the United States formed the North American Air Defense Command, or NORAD, to operate the continent's early warning front line against attack by the Soviet Union. To detect incoming bombers, Canada and the U.S. cooperated to build a series of radar outposts across the far north. The Dew, Mid-Canada, and Pine Tree lines provided early warning of enemy attack over the North Pole. But the new defense system suffered from a fatal flaw. NORAD headquarters was an old hospital building, a masonry structure built in the 1920s. A direct hit from an old-fashioned conventional bomb could have knocked it flat. A nuclear attack would have turned it to dust. In 1956, the Continental Air Defense Commander reported that a man with a bazooka passing in a car could put the establishment out of commission. To fight its Cold War with Russia, America had to build something previously unimagined. A hardened command center that could survive the devastating power of an atomic bomb. The daunting challenge for military engineers was how and where such a building could be constructed, or even if it could. With America in daily danger, they had to succeed. The RAND Corporation, a defense think tank, recommended locating the base underground, if possible within a granite mountain. Military engineers combed the front range of Colorado's Rocky Mountains in search of a suitable site.
The site was eventually chosen in Cheyenne Mountain, south of Colorado Springs, which is a great big blob of granite. And it was chosen because it was the hardest and strongest rock around.
Besides its granite core, several factors attracted NORAD designers to Cheyenne Mountain. It was near the geographic center of North America, far from Soviet strategic bombers, in a relatively inactive geological region, and near an existing military base at Fort Carson, Colorado. The engineers had their site. Now, how could they carve such a massive structure out of solid granite? Hard rock miners had the technology, but no one had ever tried a project of this scale before. Work on the massive caverns began in June of 1961. The miners made quick progress. In only 1 year, they blasted loose and hauled away over 1 billion pounds of granite. But suddenly, their work took on a desperate urgency. In the fall of 1962, the Soviets suddenly brought the nuclear threat to America's front porch. Aerial photographs revealed that the Russians had placed missiles capable of carrying powerful nuclear warheads on the island of Cuba, a scant 90 miles from our nearest shore. Both sides went nose to nose and prepared for the worst.
Fortunately, most of the American public wasn't aware it was that close till afterwards.
We were redeployed to the reserve position very deep in the mountains from our permanent location and received weapons, ammunition, gas mask, special clothes for the protection against radiation and all other stuff. It was good luck of our mankind that we had the chance to avoid this war.
I knew that a fallout shelter wouldn't help you. And actually, I took the attitude, if a war happened, a nuclear missile attack, I'd be dead. I wouldn't have to worry about it.
After 13 days of tense negotiations, the Soviets withdrew their missiles from Cuba. Tempers cooled, but the arms race continued to escalate. The near apocalypse of the Cuban Missile Crisis made the successful completion of the Cheyenne Mountain Complex even more important. In the wake of the Cuban Missile Crisis, work proceeded on NORAD with an even greater sense of purpose. The project was put on what is called a wartime construction schedule. It was to be completed as soon as possible. Everyone involved with the project knew what was at stake, nothing less than the continued existence of the free world.
Hey, good one, Carl. Finally.
Today, you might never guess that the free world's survival once depended on these old friends who still play golf together in Omaha. In the 1960s, they were the rising stars of the Army Corps of Engineers, charged with the seemingly impossible task of building a nuclear bomb-proof NORAD.
It was an elite group of, what we considered ourselves elite at least, group of people that were good structural, electrical, mechanical engineers that were giving super challenging problems.
As far as I know, there were no projects designed to withstand the effects of a nuclear explosion.
The most important requirement of the underground facility was its ability to survive a nuclear blast. Before work began, geologists and soils engineers drilled test holes to discover if the rock would support the enormous cavern that needed to be hollowed out of the belly of the mountain. The military engineers had plenty of experience in underground tunnels and mines. But blasting a hole inside Cheyenne Mountain would be like no mining project ever conceived. NORAD headquarters required far more space than a mining tunnel. At first, this seemed to be no problem. The miners were very good at blasting and removing massive amounts of rock, but this project required more finesse. The rock chambers had to be excavated to a very specific size. The remaining rock had to be structurally solid. Normal blasting very effectively removes the maximum amount of rock in the shortest possible time, but it's very destructive. Blasting inside Cheyenne Mountain threatened its overall stability. But it was not enough just to smooth the cracks in the cavern. The engineers also needed to strengthen the hollowed-out sections of the mountain so that it could withstand the power of a nuclear blast. To do this would require taking a mining technology to a level where it had never been before. And the result was one of the greatest innovations of Cheyenne Mountain, rock bolting.
I think it's kind of interesting not just how they removed the rock, but how they left the remaining rock in place with rock bolts. There aren't too many people that are familiar with rock bolts.
The rock bolts used in Cheyenne Mountain were metal rods 6 to 30 feet in length that were similar to but much larger than the expansion bolts used by the home do-it-yourselfer to anchor objects to a concrete or brick wall. But these bolts, an unprecedented 115,000 of them, kept a half-mile thickness of granite from falling in on itself. Each bolt was torqued to 275 foot-pounds. A 1-inch diameter, 6-foot-long bolt created a tension of 10,000 pounds on the exposed rock face. This tension fooled the mountain into thinking it still had a center. Just as the engineers began to believe that they had conquered the interior challenges of Cheyenne Mountain, a shocking discovery threatened to derail the entire project for good. They found that the mountain had a fatal weakness.
When they picked the mountain, they thought it was going to be the best mountain in the world, but when they got inside of it, they found it was rotten in the core.
To make matters worse, this fractured rock zone was precisely over the tunnel intersection where NORAD's Operation Center was to be placed.
The collection of joints was known as a shear zone. It was an area where the rock had been sheared apart in ancient geology. If the shock wave had come across the unreinforced chambers with the weak rock would have been squeezed out into the chambers like toothpaste out of a tube and would have crushed the buildings and filled the chamber.
The nearly completed project was in serious jeopardy. Unless this massive natural shear zone could be reinforced, Cheyenne Mountain would be abandoned. Kiesel went back to the drawing board to figure out a way to overcome Mother Nature's capriciousness.
I went back to New York and devised a concrete sphere that would be constructed inside the mountain at the intersection of these two chambers. And the sphere could withstand the squeezing pressure of the weak rock being tended to be squeezed out and hold it in place.
This dome, although unplanned, is one of the greatest engineering marvels of Cheyenne Mountain. It took nearly 2 years to complete. The form for the dome was constructed outside Cheyenne Mountain. Once complete, it was then disassembled for the move underground. At 100 feet in diameter, the form was a mammoth jigsaw puzzle. Putting the pieces back together inside the mountain presented Kiesel and his team with another challenge.
The construction of this was more of a problem than the design. The chamber had to be enlarged in order to make room to put this concrete sphere in place.
Expanding the excavation only added to the instability inside Cheyenne Mountain. The engineers would need another innovation to keep the project alive. Kiesel came up with the answer over lunch while visiting the Army Corps of Engineers headquarters.
I remember sketching this idea out on a napkin in a cafeteria in Omaha. So we came up with a very strong steel tower composed of heavy steel columns laced together, which was jacked up against the roof.
Workers poured thousands of yards of concrete to create the structure that would transmit the weight of the mountain around the fractured area to the solid bedrock below. While work on the steel tower and concrete dome added months to the project, the urgency of completing NORAD's command center never lessened. The miners and excavators gave way to the welders and steel fabricators. Construction never stopped on the steel buildings in the completed underground chambers.
You had to bring a 40-foot building to a 15-foot diameter tunnel, so it all came in pieces and all had to be welded together underground in the middle of the cavern. People worked night and day on this.
Despite the added work over the command center, NORAD's interior protective shell was finally completed in May of 1965. The steel buildings that would eventually provide 208,000 square feet of working space took their place within the 2.5 miles of tunnels in the cavern. Now it would take 8 months just to install the complex electrical and surveillance equipment inside the mountain. By today's standards, NORAD's initial computer technology was primitive. But at the time, the massive mainframe computers were state-of-the-art. Throughout the Cold War, the computer technology race was as fierce as the nuclear arms race. Today, NORAD's Granite Sentry system remains state-of-the-art.
All the computers we use are off-the-shelf items. It's just a software that is specially designed and created to perform the missions that we require of them. Basically, we have our fingers on the pulse of Cheyenne Mountain. We can tell at a glance if there's a problem with our missile warning systems, our space defense systems, or our air defense systems throughout the mountain.
By early 1966, the power was on at Cheyenne Mountain. The sentinels at their stations. Everything waited in readiness for an event everyone hoped would never happen. After nearly 5 years of work, at a present-day replacement cost of $18 billion, the Cheyenne Mountain Complex became fully operational on April 20, 1966. The men who designed, engineered, and built the massive underground center were proud of their work. They were also quite aware of its limitations. Everyone hoped that this superstructure would never be put to the test. Even more, they prayed that it would survive that test.
The design was based on that premise. Well, the odds were rather high that you would not have a direct hit on the complex. If you had a direct hit, then the dynamic loads would be so great that the openings would collapse. There's just no way to offset the terrible stresses that would be developed in the rock.
In the end, NORAD's survival rested on a principle called circular error probability. CEP was simply the probability that a nuclear weapon fired from halfway around the world would fail to score a direct hit on Cheyenne Mountain.
As far as the vulnerability of NORAD, that was really mostly a function of the accuracy of the device. Because, you know, it was a foregone conclusion that a direct hit would destroy it.
Even though it cannot survive a direct hit, the command center is designed and built to resist the effects of a nuclear weapon. Blast, heat, seismic shock, electromagnetic pulse, and radiation. The access tunnels weaken the effects of blast and heat simply by letting the blast wave pass through the tunnel unimpeded. To avoid a direct strike by the blast wave, the designers located the blast valves and blast doors at right angles to the tunnels. At the first sign of a credible nuclear threat, the blast doors are closed and Cheyenne Mountain is sealed off from the outside world. Another engineering innovation at Cheyenne Mountain is designed to protect NORAD from the seismic shock of a nuclear blast. Massive steel springs, more than 1,300 of them, support each of the 15 buildings in the complex.
Each spring is about this big around, and the wire that makes the spring is 3 inches in diameter of high-strength steel. And the purpose of the springs for all these facilities is to prevent a shock that might come through the rock resulting from either a man-made or a natural shock. These springs will attenuate that shock just as they would car springs on your vehicle.
NORAD's gigantic springs work so well that the concept of seismic shock isolation has been incorporated into many modern buildings in earthquake zones. Flexible passageways and couplings allow the buildings to sway independently without breaking vital connections. But the designers needed even more reinforcement to meet the challenge of a nuclear bomb's electromagnetic pulse, or EMP. This tremendous burst of energy, similar to but far more powerful than a lightning strike, can destroy sensitive electronic equipment and damage even sturdy electrical circuits. To combat its effects, the engineers constructed the buildings like the hull of a ship or fuselage of an airplane. The continuously welded 3/8-inch thick steel skin gave structural strength as well as electromagnetic pulse protection. The day-to-day operation of this complex facility must seamlessly support the primary defense mission of Cheyenne Mountain. A reliable source of power is absolutely necessary for the complex network of critical electronic equipment.
Right now we are in the bowels of Cheyenne Mountain. In fact, we're at the lowest excavated point within the complex. Behind me is a 500,000-gallon diesel storage reservoir that we use to power our generators in the event that we need to go to generator power. And this reservoir will permit us to run for an extensive period of time if we should lose commercial power.
Even the backup power has a backup. 3,400 powerful battery cells maintain what is called uninterruptible power supply, or UPS, for the operation of NORAD. It is one of the largest backup power systems ever built. Perhaps the most important supply for the operation of NORAD is water. More than 1.5 million gallons of drinking and 4.5 million gallons of industrial water are stored here. Cheyenne Mountain must also regulate its air supply. Air enters through two sources, the north and south portals, and then is directed through a so-called air delay path. This construction is crucial to prevent damage from the force of a nuclear blast and the pressure pulse it would create, a destructive blast of air traveling at the speed of sound. The air delay tunnels are equipped with blast valves, one of the ingenious design elements of Cheyenne Mountain's respiratory system.
If a blast occurs and that pressure pulse drives up the tunnel, that pulse will hit a disc located on the back side of this valve and drive that disc across these slots, preventing any air from entering the complex.
The mountain must also be able to repel chemical, biological, or radiological contaminants. To combat that threat, the engineers can force outside air through sophisticated CBR filters in the cooling towers. Cheyenne Mountain is more than just a panoply of technological wonders. It's a place where people live their lives and do their jobs. More than 1,200 people keep the complex functioning on a 24-hour-a-day, year-round basis. At any given moment, there are as many as 800 highly trained people working inside from a collection of 12 government and civilian agencies and from the combined branches of both the U.S. and Canadian Armed Forces.
Each of those individuals is very carefully screened, and they represent the very best that their services and their country have to offer. It's incumbent upon me to make sure that those people who work shifts do not develop a false sense of security of sitting in a command center, staring at a blank screen for 8 hours a day, and then going home.
Security is tight, not only getting into Cheyenne Mountain, but also in getting from area to area within the complex. For more than 30 years, the NORAD Operations Center in Cheyenne Mountain has faithfully fulfilled its mission. But was that mission necessary, or was it Cold War paranoia? Now that the Cold War is over, we know that the Soviet threat to North America was real. The Soviet plan for global thermonuclear war was revealed in a 1985 report. It consisted of a surprise attack that would be launched on several fronts. Land, sea, and air-based elements of the Soviet military forces would simultaneously attack targets in Western Europe and in North America. The first barrage would destroy U.S. coastal cities and create an electromagnetic pulse that would disrupt satellite and ground communications. The Soviets estimated that in the first 20 minutes of this massive nuclear assault, 75 to 125 million Americans would be killed. Cheyenne Mountain was high on the list of primary targets. The Soviet attack never came. The Cold War is over. Some say NORAD has outlived its usefulness. Others say a threat is still present. It has only changed hands. Cheyenne Mountain was inspired by a time when the Cold War threatened North America. Originally designed to combat the threat of Soviet bombers, its priority shifted to monitoring Soviet missiles even as it was being constructed. During the 60s and 70s, the United States and the Soviet Union played out a danse macabre of nuclear missile superiority to the inexorable beat of mutually assured destruction. The Soviets never achieved numerical superiority, but they built bigger missiles with more powerful warheads. Both nations relentlessly added to their stockpiles of destructive power. Their combined arsenal held enough firepower to destroy the world more than a dozen times over. For all this military buildup, Cheyenne Mountain has entered an advanced state of alert only once in its history. It was in October 1973, during the Yom Kippur War, as the Arab allies advanced on Israel. America ordered B-52s armed with nuclear bombs into the air. American missile launchers went into a pre-launch check as NORAD monitored the war. The American military was placed on defense condition, or DEFCON 3, an advanced state of alert halfway between peace and thermonuclear warfare. The alert warned the Soviet Union's Arab allies that an invasion of Israel would not be tolerated. The advance was halted and the alert relaxed. Then, in the late 1980s, the Soviet Empire collapsed, and with it, so did much of its nuclear threat. Today, the Cold War is over. NORAD has been forced to redefine its role, yet its mission remains the same. Make certain that nothing enters U.S. airspace that we don't know about. And today, there are many more potential threats. Some of them are external, from new nuclear states, like India, Pakistan, North Korea, or from former Soviet republics. Iran and Iraq could soon join the nuclear club. And China already has nuclear-capable ballistic missiles. Conventional weapons remain a threat. During the Gulf War, NORAD closely monitored Iraqi missile strikes, coordinating with Allied theater commanders in Saudi Arabia and Israel. It was able to issue warnings of Scud missile launches that were relayed to troops on the ground. The same technology is also being used to stand watch over possible airborne attacks from terrorist teams looking for an American target. NORAD also protects against enemies from within. By tracking all aircraft movement in and out of North America, it's a powerful resource in the war against drugs. Thanks to the ever-watchful eyes of NORAD, there have been a number of dramatic interceptions of drug traffickers in North America. NORAD even monitors threats from outer space. International treaties ban the deployment of weapons in space. The Space Control Center tracks every object that orbits the Earth from an altitude of 200 miles all the way out to 22,500 miles. Nothing goes up into space or falls out of it without the center knowing about it.
We've been doing this ever since Sputnik launched in October of 1957. Object number 1 is the rocket body from that launch. Sputnik is object number 2. We're currently up to 25,484.
Over the years, NORAD has become a kind of near-space traffic cop.
We'll use the shuttle as an example. While it's on orbit, we will build a 10-kilometer by 50-kilometer long theoretical box inside of our computer. We'll compare that to the 8,200 objects that we're tracking for 36 hours. If any of those objects penetrate that box, we have a hotline to the flight dynamics officer at NASA, and NASA is the one that makes the decision to maneuver the shuttle. In the 91 missions, they've maneuvered 7 times to avoid an object. The support for the International Space Station will be quite similar to what we currently provide for the shuttle and the Mir Space Station. The only difference will be we will have a dedicated person to support that mission, and it will compare all the objects that we're tracking for 72 hours vice 36 hours that we do with the shuttle.
Since its Cold War origins, this engineering marvel has matured to fulfill several important roles in the technologically complex world of computers, space weaponry, satellite communications, and even the colonization of near space by the International Space Station. Yet those who built the Cheyenne Mountain Complex have never forgotten the terrifying times that gave it birth.
Children were being raised with this nuclear threat over their head. You needed to do something about it.
First, you duck, and then you cover.
When the wall came down, and essentially the U.S. won the Cold War, looking back, I feel, well, maybe I had a small contribution to that total impact. And although it was expensive, it was a lot cheaper in both money and people to go that route than to have a nuclear holocaust.
Today, the risk of global thermonuclear warfare seems like a nearly forgotten nightmare. But other bad dreams have sprung up to take its place. In the post-Cold War world, a threat to peace can come from any direction at any time. Many believe there is no foreseeable end to NORAD's mission. The engineers and builders who met the challenge of constructing this superstructure did much more than confront the Cold War's nuclear threat. This monument to their ingenuity will continue to serve the security and sovereignty of North America well into the coming millennium.
You're watching the Science Channel. We know what you're thinking. The Science Channel? What happened to Discovery? Don't worry, only the name has changed. Same great programming, all new attitude. This is the Science Channel.